So, let's get rid of this. Hit this. There's that. All right, good. So we're down to the Mac. The Mac is much simpler than the PC section, probably because it just has been less thoroughly reverse engineered by forensic scientists. However, most people still use PCs in the rest of the nation. Out here, if you go to coffee houses or classroom, it's like 90% Macs, but all my law enforcement people tell me that the rest of the nation is still 90% PCs. So Macs use the HFS file system, and if you want to get picky, it's now JHFS because it is journaling. And HFS is something like high performance file system. So we're going to talk about the type of logs it takes and the type of data it stores. It's all amounts to about the same thing as a PC, but it does things differently, so you have to have a different bit of lore about where to look for it. But it's going to keep journals of everything it does, so that if it crashes halfway through a process, it can pick up where it left off. It's got hard links and symbolic links, which Microsoft calls shortcuts, and junctions, which are just little files that point to the location of another file. You can encrypt the hard drive, and the hard drive can get up to a very large size, just like NTFS can, and you can resize the volumes and so on. It has 9 structures on the hard disk, far more complicated than the Windows hard disk. I was just amazed the first time I ran diskpart on a Mac and found all these partitions. And a lot of them are not really used anymore. But you can see them, the anatomy of a disk. So the boot block is not used anymore. In Windows, you start with this MS-DOS leftover thing called the master boot record, and Linux just has that thing full of zeros now because it has, Mac does. So the boot box is typically empty. The volume header has information about the volume, including where all the other files are. And it has a whole series of fields, and at the bottom it tells you where most of these other files are. The allocation file, the extents file, catalog, attributes, and startup files. These are all files that store where things are stored on the disk. In modern NTFS volumes, most of these things are included in what they call the MFT, the master file table we talked about before. You can download this thing, which is great fun. iBoard is the Mac disk editor, and it lets you monitor through these partitions and see what's on them. And here you just see the same thing. Here's those files in there. So you can view and edit your hard disk, which is the same thing you do with HXD and some of the projects here. Of course, viewing your hard disk is fine. Editing your hard disk is very risky, and you want to be careful, because if you mess around with these volume structures and get an error in there, the whole thing will become unreadable. Mac has a bunch of timestamps. The HFS volume has a creation date, modified, backup, and checked date on the volume itself. Each file has access, modify, inode change, and inode birth time. Inode is a Linux structure used to record a file's presence. Every file has an inode number, and Macs use it too, and so it stores forever the original time the file was created and the time it was last changed, which would be the metadata changing. You can see this stuff with the stat command. If you do stat of a file, you'll then see 4 timestamps. And I guess you'd have to run manstat to find out which one is which, but that's how you can see all 4 of those timestamps for each file. There's an allocation file, and the allocation file has a bit for every block. And 1 means it's in use, and 0 means it's available. A very simple structure. Inside, it's actually using a B tree, which is a special way of organizing the blocks so it's fast to search. But in this book, we didn't bother going through the details of that, which I think is all right. The extents are contiguous allocation blocks, which are available places to store files. And then there's the catalog file, which is, I think, the closest corresponding analogy to the master file table. This is where each file has its unique catalog node ID, and it's got the hierarchy of all the files and folders in the system. Yeah?
Is that like inode?
Yes. Okay. It's like it, but I think it's somewhat different.
Okay, so inode and this are separate.
I think so, but I'm not really sure. It's a good question. So there's an attributes file that is typically not used, but it can be used for named forks, which are what Microsoft calls alternate data streams. You can have multiple streams of data tied to the same file. And the most common use of this is if you download a file from the internet and you open it, a box will pop up warning you this file was downloaded from the internet, and that information is stored in an alternate data stream, or what they call a named fork here. You have the original file contents, and it adds an extra bit of data to that file saying this file was downloaded from the internet and therefore should not be trusted without warning the user before you run it. The startup file is another useless appendix from earlier versions that's not used by Mac. Files. So in order to find your way around the file system itself, you have 2 main tools. These are searching and indexing tools. There's, of course, Finder, which is what draws the desktop. Well, it's to Explorer in Windows, but these other two are here. Spotlight will search and it indexes files to try to make searches faster. This is something Microsoft has tried many times to do and always utterly failed. They've been trying it for 15 years to have some kind of indexing process so you can quickly find files on a disk, and all of them have the same feature that they will grind away forever and not end up making it any faster.
And you can turn it on too. Sometimes there's a little drop down, like with a little banner.
Yeah, they've been doing it for 20 years and they can't get it right anymore, and they make a search engine for the web. This is just something Microsoft doesn't understand how to do. But Apple has their version of it, and that's Spotlight. And so every time you make a file, it reads the contents of the file and it puts indexes on it so it can be searched for later. And so it has a bunch of indexers which will read inside the file. So it can read some file formats and others it can't, of course, but anything more or less like a text format, it can read the full text and make index entries so you can search for it later. That sounds pretty good. That's the kind of thing that would be valuable for forensic investigators, but unfortunately, when you delete a file, it efficiently deletes all the index information too. So it really is only useful for a live acquisition. There's nothing in here that records the past history of the thing, and that's usually what forensic investigators are most looking for, is something that persists after the perp has deleted the files. And this is not it. Managed storage is it. Managed storage is analogous to Microsoft's volume shadow services. This is something that continuously your app can now save data all the time. Remember back in the old days of MS-DOS and Windows 95, your computer would crash and you would lose your work because you didn't save it. And so Microsoft put like an automatic save every 10 minutes in Microsoft Office, and there are other things that save periodically, and that's what this thing does. It runs this thing called Revision D, and it saves a whole series of old versions of your files, which is bloody awesome. And so these things are DB files. The originals are locked and in use, and you can't open them, so you copy them somewhere else. So I elevated myself to administrator, and I copied this file, document revisions DB v1, and here it is. It's a SQLite database, which is what Microsoft Windows is what Macs like to use. And so you have to get a SQLite viewer. There's a variety of them you can download. I found this one called DB Browser that works fine. And now this shows you can open the database structure. You don't open the files database. You can find the name of the file. Here's a page about a class I taught about a year ago. This has index file stream ID 6. And you can open another thing called Generations, and you will find 394 versions of this file saved, which is bloody awesome. Microsoft has a thing called previous versions, and it usually only has 2 or 3 previous versions. I don't know if these are all complete. That would be hard to believe, but it appears to have saved the last 394 versions of this file in some form.
It would just be the diffs.
It could be just a diff. But in any case, it means that if the perp tried to delete it or get rid of it or change it, I can find out what it used to look like. The only thing I know that is this awesome is Dropbox. Dropbox has, by default, the last 30 days of everything, even if you deleted it on the cloud. So sending a subpoena to Dropbox is like the greatest way to find out what people have been doing, even when they think they've hidden their traces. All right, so I got some iClickers about that stuff. Come grab one if you need one. All right. See if this thing is going to work or what. Yes. It's supposedly working, and then where is it? Yes. Oh, here it is. Okay, good. All right. All right, so where are the CNIDs? Actually, it's pretty easy to get by process of elimination. I'll quit at 30. All right, they are in the catalog file, like inode numbers, something node IDs. All right. And where do you find a bit for every block? All right, looks like I can quit at 25. All right, that's the allocation file, showing whether things are allocated or not. All right. And, all right, which one indexes files by content, but it deletes the index when the file is deleted, making it of limited use to us. All right, I guess I'll quit at 25. I think the answers are in. All right, and that is Spotlight, which is this thing, Spotlight, thing that searches for things.
What's managed storage?
Managed storage is the one that keeps all those old versions. All right.
Sorry, it's probably the next question.
It might be. It might be, but that's all right.
Everyone wins.
That's all right.
Everyone wins.
And that's it. Go ahead. Well, you know, in the past, I frequently find that it makes no difference.
Yes.
Because
Statistically speaking, it should
this is,
make no difference.
a lot of people are not listening. So, this is a sort of psychology
Or
test.
surfing on the internet.
Or, you know,
Talking to the airport time.
you could enter the domain of like religion and try to figure out what they're thinking. But anyway, they're often not paying attention to clues like that. Let's see. However, in this case, I think some people were listening. All right. So anyway, well, that's fine. That's why these things are extra credit. They're not perfect by any means. They're mostly just there so you don't fall asleep. All right. So then you got the operating system is here. So there are 4 domains for data classification in the Mac: local, system, network, and user. And they serve different purposes. So the local domain is things that are shared among all users on the system, and that is applications, developer, and library. And these are, slash means they're from the root of the system. These are not owned by any user. They're not in the user profile. They are global settings that affect the whole machine, like the registry settings that are outside each users, like we talked about. There are the main registry hives affect the whole machine, and then the ones in user profile affect you when you log in. And it's the same general principle here. Yeah?
In Windows, how does this relate to the Windows local service or local?
It's not so related to the services, but it is related to the registry. Like there's part of the operating system that runs before you log in, and that's not personalized. And then there's part that comes in when you log in, and that's personalized, and it's in your profile. So this is the part that's outside your profile that affects the whole machine. So in the system domain, you'll find, that's the local domain, affects the whole machine. The system domain is the Unix operating system. This is where you find the typical Unix folders like bin and user and dev and all that jazz. Again, not tied to any user, and it contains things installed by Apple and certain low-level utilities. And this is very useful because it contains the Unix logs, which record many things going on. All right. Then there's the network domain, which typically has nothing in it. This is only used if you use your Mac as a file server to share files with other people. And Microsoft and Mac has a bunch of features to do that, but most people don't turn it on, and so there's nothing in there. But if you have been sharing folders with other people, like to have streaming media or something, then they'll be in here. The user domain is, of course, everything in /users, which is customized to each account. So it's got your documents, your desktop, and all that jazz. Configuration data tied to one user. And all modern software installs, and it encourages you to save all your documents and settings and everything in your user profile, just like on modern versions of Windows. But again, just like Windows, if you are a hacker or a old school programmer, you can save your stuff other places outside your profile, the way everything used to work. And so you can't make the assumption that all user created data is in here, but all user created by non-technical people will be in here. It's the only folders you see on your desktop that invite you to save things. You can use other things. You can use MacPorts, for example, which is quite useful. This gives you a bunch of command line tools from BSD on your Mac. And it's you can also write and compile your own code. And if you're doing that stuff, you may very well be creating stuff that does not go in your profile. All right, so in more detail about these, the local domain is /applications. Every application on the Mac is essentially here. It is possible to leave it somewhere else. When you install it, it'll say, now drag it into your app folder. You could choose not to. I do this sometimes when I run something. I don't know if I like it. I just leave it in the downloads folder, run it a few times, and then I just throw it away. Never even put it in the applications folder, but this is where they usually go. Applications are stored as what appears to be a single file, which is very different than PCs. PCs have an installer, you run it, it puts it in the registry and everything, then you throw away the installer. Macs have this bundle file, you put it in the app folder and it just sits there, and that thing is a folder, but it looks like a file. So everything is in one apparent file, all the graphics, all the libraries, everything. It treats it as a single file, and it ends in like app, framework, plugin, or KX for kernel extensions. Be cautious with kernel extensions. I rendered my Mac completely unbootable while installing one at a conference recently. Some security feature was supposed to make my Mac safer. Well, it made it too safe, so it wouldn't do anything at all. And the developers seemed not to care when I said, dude, your thing killed my Mac. And he said, oh, it looks fine to me. I think I'll leave it this way. I said, well, I think you and I are going to part company. We have different attitudes about software. But anyway, so you can look in the bundle by right-clicking and show package contents. That opens it, and then you'll see subfolders, which aren't always there, but it's what you typically see: Mac OS resources, library, framework, plugins, and all that jazz. And the developer could choose to put anything in any of these folders, but there are best practices and recommendations. VMware puts command line utilities here you use to control your virtual machine. And so here's the console app, which is what gives you a command prompt. It is surprisingly complicated. If you open the console app container into the contents, you'll then see someplace is the actual executable down here. This is the actual executable, and all the rest of this stuff is like foreign languages, resources, and stuff. But anyway, it's complicated enough. Even the very simple thing has many files inside there. So inside there, all these little objects have their own creation dates and metadata. So there's tons of information. Now, normally for a commercial application, these are all just the time the developer compiled them or something, or the time you installed it on a machine. But if you're messing with it and altering it and putting in new files, they might have a timestamp that sticks out. And this is a place you can certainly hide data inside a container or something. It's certainly a place where it wouldn't be obvious that you've hidden some other data in there. Then there's /developer, which is where Xcode wants to store things by default. Xcode is Apple's software development environment that they expect you to download and use if you're going to write Mac code. It was moved in later versions, but this directory called developer may still be present. It's not on my Mac, but my Mac is fairly new. System library and library are where you have library settings. These are settings shared between users. Those are app settings for the operating system, and the user-specific settings are in your home file, user's username, and the library there. This is just the same in PCs. There's a thing called app data that serves the same purpose. These are settings for a particular program. Some of those settings are global, like how big is your monitor and what printer are you using. Other ones are local, like what's in the name to put at the top of my Word document and what's my phone number and stuff like that. So there are multiple configuration files storing settings for each app. And then application support, this is probably one I should refer to even more being like app data, but it's the same kind of thing: license information, personalization setting for applications. And then caches, which is temporary data just like a browser. Every app has temporary stuff, and they have a cache where they store things just to make it run faster, and they have some period of time for which things will be preserved before the cache gets emptied. Typically it has something like a maximum size, and after that it throws away the oldest entry to make room when it's time to put more stuff in there. Then there are frameworks. These are helper applications and drivers and stuff. Typically nothing important to us, typically just something that a developer is using. And there's Keychain, which is good, clean fun. You can't, if you have an app and it needs something like a password, you could write your own code and store the password in some file and have some kind of decrypting thing, and this is highly not recommended. Apple has provided the Keychain to store secrets, and it is supposed to be the safest place to put it, and you are highly encouraged to use their API calls and correctly store your secrets in the Keychain. Yeah?
But I've met people who even work at Apple, and they're like, the keychain doesn't really work as well for developers. Like, it doesn't store as many things as you want, and sometimes it doesn't return them at the pace you need them back.
Yeah, there's always annoyances, but the security people generally recommend it. But anyway, it is there. It's where most apps do store their stuff. And the point here is it's got these secrets, and you really have to have the user's password to open that user's entries in the keychain. Yeah.
Yeah, the login's fine, but if you just want to store data securely,
yeah,
you technically could use it, but they're like, don't do that yet.
Yeah. I think what you do is encrypt it and then store the password in here or something like that. Yeah. Anyway, then there's logs all over the place in the library, and use your username library. These are application logs. These are quite useful. These will show when things have been launched, when error messages occurred, when sticks were plugged in, things like that, sort of thing you want to know. And then there's preferences. If the application uses the system API to manage its preferences, you'll find those preferences stored here in plist files. And they say this is like the software hive in Windows and the registry. There is no registry on the Mac. It uses the Linux convention and Unix convention of storing little files all over the place to store all those settings instead of sweeping them into one giant database the way Microsoft did after DOS. And then there are these things called receipts, which I thought were kind of novel. When you install an application, it puts receipt files recording the fact that you installed that application and when you did it and exactly what you installed, which is, I do not know what value this has except for us. It's very handy for forensic examiners to store that kind of information. So you've got two files here. You got a plist here and another file created when you store them. We'll talk more about it later, I think. You have a web server. Apache is installed in every version of Mac OS X, which baffles me how many people want to run a web server web page off here, but it's an option. I would assume most people don't have it. There's a thing called web sharing you can turn on, although I don't know why you would want to do that, but it is an option. All right, so here's file types. The most common types are plist files, which you can, are binary files, and you can view them with PL-util, and then SQLite databases, which are also binary files. You can see the strings more or less, but it's better to have some kind of SQLite browser. And there's a Firefox plugin to do it, and there's a free download you can use. And then you can see the contents in a more convenient form. So here's more of these iClickers. So which domain has the logs? The system logs, I should say. Technically, there can be other logs elsewhere. I'll quit at 25. All right, and it is system, which is where the Unix file system is. It's got syslog and all that jazz, where you figure it would be. The names are much less baffling than the Windows names. The Windows names are older, and typically the rule is everything is named the opposite of what it should be named. But it's not that much true on the Mac. So where are the etch and bin folders? Etsy, perhaps? I don't know how you're supposed to say it. Etsy, I think, yeah. There are even like Wikipedia has pronunciation for Linux things.
Well, Damon, I don't know.
No, it's a folder.
It depends
But
what
Damon is
country
another
you're
one where you might argue about how to pronounce it. Yeah, what's that?
from. It depends what country you're from, because like if
Oh.
you
Can't say
are in a
demon?
foreign language, like we work with some Italians, and instead of saying Apache, they say Apache.
Oh, yeah.
Just so many little.
Demon,
Oh, yeah.
Etsy.
Anyway, those are in system. And let me go back and make sure I'm not lying to you, since it's so unpopular. There's the system domain. That's what's got the traditional Unix structures. That's where syslog is, and that's where opt and all the typical Linux folders
I
are.
thought the user had a lot of, well, I guess that has most of Linux.
Now, the Linux file structure, like /bin, /hbin, and all that jazz, is in the system project, the system part of the folder. All right.
But inside local, there is /user/bin, but it's not.
It's not the same. Yeah,
it's not
yeah.
top directory.
That's right. It's not the /bin directory.
Yeah.
It doesn't serve the same purpose as the root directories in a Linux system. All right, so where do you find all the apps? All right. I'm going to have to go back and look. I'm quitting at 25. I think it's local, but let's go back and see. It's either local or system.
It's local.
And so it's not part of the Linux system. It's the local, that's where apps are. These things are in a separate place than a typical Unix file system. All right. So it is local here. All right. And do I have another one? I do have another one. All right. So which one is empty? Another one after this too. I'll put it 25. All right, and that is network. Typically, Mac users are not sharing anything here, and there's nothing in there. All right, which one requires the user's password to open? Put it at 25. All right, and that's the keychain, of course. We talked about that, where it's intended to be the place you store your secrets. All right, so let's pick up at 5 after 7. Give you a 10-minute break and we'll carry on with more of this. This is chapter 13.